Okay, Calc. Yesterday we did a little bit more work on section 4.6 notes, and it was a little bit confusing, like position, function versus velocity versus acceleration, whatever. I'm going to do my best to try to unconfuse you today a little bit, maybe, hopefully, but I'm going to kind of like do some stuff out of order. So I'm going to have you go down here to example 6. We're not going to do example 6, but I'm going to use this little area down here to like map some things out for you, okay? And then maybe we'll go up and do example 5 and we'll answer some questions up above here, okay? But let's go down below example 6. You can cross this guy off. We'll just wait to do functions like this, like to the third power, until we understand what like the curves mean, okay? So if we're talking about a position function, okay, this is like represented by S of t, okay? I'm going to draw 4 different graphs, and I'm going to make them look like this, because you can have like your position and your time. You can have your position be positive or your position be negative. And the same thing with velocity and acceleration. So I'm going to have your velocity, your v of t. I should put velocity here. Velocity, and then acceleration is going to be over here. And that is going to be a of t. Okay, and I have this going on here. All right, and I'm going to draw 4 of these, see if you have room. You're going to run out of room, but I'll move him down here. Okay, so we've got 4 position functions, 4 velocity functions, and then 4 acceleration functions. Okay, so we'll go through and we'll map out what each one of these looks kind of like. Sorry, I'm trying to do this with a sleeping baby in my hand, so my pen is not wanting to write very good. Okay, all right. Okay, so let's look at like the 4 different kind of curves that we could have. Okay, we could have a curve that is looking like this. We could have a curve that's looking like this. We could have a curve that's looking like this, or we could have a curve that's looking like this. So it's kind of like concave down, concave up, increasing, decreasing, that type of thing, okay? And we'll link that back to what we know about those things here in just a second, okay? So stuff like that, those 4 things could be happening. Position function, so this is like a particle that's moving uphill like that, okay? So get those 4 written down, and then we'll talk about what the velocity is doing and what the acceleration is doing, okay? So I guess if you need to pause, you can do that too. Okay, so looking at this first graph, okay, let's talk about this. If you were to draw like tangent lines across this, okay, what's happening is that those tangent lines are becoming, the slope of those tangent lines are becoming steeper and steeper. Like maybe this slope down here was, I don't know, like 1/10, right? Versus this slope up here is going to be like, I don't know, 8/1, right? Like it's going up 8 and over 1, right? So it's getting steeper and steeper and steeper. And the deal here is that velocity is represented by the slope of this function, right? So the slope of that function. So my slopes are going from lower numbers to really high numbers, and they're positive. So the graph of my velocity function is going to be over here, and it's going to be up above, not down below here, because it's positive and not negative. And it's going from really low numbers to really high numbers like this. That's what's happening to my velocity function, okay? I'm starting with numbers close to 0, and I'm going up to close to like high numbers like 8 or whatever. That's what's happening to my velocity, okay? Let's hop down here and let's do this one. Here, I'm starting with steep numbers, and I'm leveling out to numbers that are close to 0, right? So again, the slope is represented, or the velocity is represented by the slope of the graph before it, right? So I'm starting with really, really steep numbers, and I'm going to really, really small numbers, but my slopes are still positive, so I'm still going to be graphing up here in the top quadrant, right? But here I'm starting with steep numbers, and I'm going down to numbers that are close to 0, okay? So that's what my velocity function is looking like, okay? I'm going downhill in that direction, okay? Now, these guys, my slope, again, velocity is going to be the slopes of these guys, the slope of my tangent lines. So here's all my tangent lines. Here, my slopes are going to be negative, right? Like each one of these slopes is negative. It's on a negative line. And I'm going from steep numbers, so high numbers, to low numbers, but I'm negative, okay? So high numbers until I get close to, like, here would be 0. So this is going to be down here on the bottom. I'm starting with steep numbers, and I'm going towards 0 because I'm leveling out, right? But I'm negative because my slopes are all downhill. And so this is what my velocity will look like for that one, okay? This one, my slopes, again, are negative, but I'm going from really low slopes, like close to 0, close to a horizontal line, to really steep slopes. So I'm starting with 0, and I'm going really big negative like this, and that is on the negative end, again, because my slopes are negative. So again, slopes of the curve before it is going to tell what my velocity is doing. So here's my velocity curves, and notice that all of these are straight lines, because when we deal with curves that look like this, say this looks like this is a part, this curve is part of like an x squared function, right? That's the only part that we can see of it. We don't necessarily know that it's an x cubed function because I don't know what's happening outside of this thing. But this would be an x squared function, okay? Which means the derivative, the velocity, would be a linear function. It would be an x, right? And then if we go over here to acceleration, which we'll do here in a second, it is going to be a constant function. So like just a number, right? Okay, and we'll talk about what that means. But x squared is kind of like what just one little curve or one piece of a curve looks like. And then acceleration, or velocity, excuse me, velocity would be the derivative of that. It's going to be some form of x, or like 2x, I guess in this case. The acceleration would be like 2 or whatever. Okay, so let's talk about the acceleration in relationship to the velocity. So acceleration is the derivative of velocity, and derivative is the slope of the tangent lines. So if I draw dots along here, my tangent lines are going to actually be all the way along the graph. And each one of these tangent lines that's touching all the dots along that graph are all going to have the same slope, which means my slope is going to be constant, right? My slope, m equals a constant slope, which means I'm having a constant acceleration all the way through, but that acceleration is positive. So he's staying the same all the way across, but he's on the positive end because he's up above, okay? So constant acceleration, same slope, or same level all the way across, so he's going to be a straight horizontal line, okay? This one, again, I'm looking at my tangent line, so if I draw dots all along this curve, my tangent lines are going to look like this, except those are all the same number, right? My slopes for each one of these lines is going to be the same. This is the same slope here as it does here, as it does here. Those are all the same slopes, so same number going all the way across, except it's going to be negative. So that is going to look like something down here, right? That's what my acceleration will look like. He has a negative acceleration. That just means, that doesn't mean I'm decelerating. I'm still going the same acceleration. It's just that I'm going in a downward motion, okay? All right. So I think yesterday when we had something that looked like that, we had like a negative for an acceleration. We're like, does that mean we're decelerating? And I think I said, yes, that means we're decelerating. I was wrong. That does not mean decelerate. That means I'm just going, like I'm falling toward the earth, but I'm still going the same acceleration, okay? Here, okay, again, if I draw my tangent lines, all of those are going to have the same slope, but again, we're going uphill, so I'm going to have a positive. So he's going to be wherever this is at here, okay? This guy is negative tangent lines, okay, but same slope for all of them, so my acceleration is going to be negative on this end, okay? Now, here's the deal. We can look at this and we can say, okay, this graph right here, for my velocity, this curve was all positive, right? All positive because he's above the x-axis here, right? This one is also positive because he's above the x-axis here, so that's positive, positive. This guy, even though he's going downhill, that's still positive, above the x-axis. This guy, though, is negative. He's below the x-axis. Okay, we'll talk about what these positive negatives mean here in a second. This guy is below the x-axis. He's negative, okay? And this guy's above the x-axis, which means he's positive, okay? This guy's below, so he's negative, and this guy's below, so he's negative, all right? Now, let's look at this in terms of things that we already know. We know increasing versus decreasing for first derivative. We know that a function is increasing if it's positive and it's decreasing if it's negative. So let's look at these curves. This one was positive, this one was positive. That means he's increasing and he's increasing, which both of these graphs are doing. Okay, down here these two were decreasing, decreasing, decreasing. That's what both of these graphs are doing. Okay, now over here the second derivative talks about concave up versus concave down. If it's positive, it's concaving upward. If it's negative, it's concaving downward. So this one, this first one, and this third one are concave up, concave up, concave up. That's true. The second one and the fourth one are concave down, and concave down. So that can tell you, you know, like now that we know that that's a thing, this can help us figure out our velocities. So here, I know he's increasing, therefore my velocity must be positive. I must be going uphill, right? Here in this graph, this function is decreasing, so I know my velocity must be negative. I must be falling toward the earth or whatever, right? This guy is concave down. That must mean my acceleration is negative. Okay, it doesn't mean I'm decelerating. That just means my acceleration is negative. Now, what does this have to do with speeding up and slowing down? Okay, so let's talk about this. Speeding up, slowing down. Okay, so I am speeding up if my velocity and my acceleration have the same sign. So if they're both positive, okay, you cannot do that. You gotta turn that down. Okay, if they're both positive, that means I'm speeding up. If they're both negative, that means I'm speeding up. Okay, we'll talk about this here in a second. Like, why is that a thing? So in the first scenario and in the last scenario, I'm speeding up. So I'm gonna say V and A equals both positive, or V and A equals both negative. If they have the same sign, then I am speeding up. If V and A equals opposite directions or opposite signs, I am slowing down. All right, let's see how that is a thing. All right, here my velocity is plus and my acceleration is plus. I am going from a zero velocity to a high velocity, let's say like 10 miles per hour, right? Okay, I'm going to a high velocity, starting at zero, going up to a high velocity. I am accelerating plus, and my velocity is plus. This velocity curve alone shows that I am speeding up. Okay, what was it? The last one. This shows that I am speeding up as well. I am going from a 0 to, let's say, a -10 velocity, right? Okay, but 0 to -10, even though that shows that I'm going down in number, right? A -10 velocity would be faster than a 0 velocity. It's just that negative velocities represent falling. So here I'm actually going faster than I am here, because 0 means I'm still, versus 10 means I'm going like 10 miles per hour, just negative toward the earth, right? So I am a negative acceleration and a negative velocity, but that just still means speeding up. Okay, let's talk about these two right here. Here I'm going from 10 miles per hour, or whatever this mark is at, down to 0 miles an hour. I am going downhill to 0, towards 0, for velocity. That is me slowing down. Same thing here. I'm going from -10 miles per hour for velocity to 0 miles per hour. That is me slowing down as well. Okay, so it's just like, has to do with, you know, like going from a -10 to a 0, that still means you're slowing down, the same way that a +10 to 0 means slowing down. Okay, so little bit of confusion, but hopefully the increasing, decreasing, and concave up, concave down can help you kind of distinguish between your curve stuff, because yeah, that's how that works. And then speeding up, slowing down, if they both have the same sign, speeding up, slowing down is opposite signs. So let's use that kind of information to try to detect what is happening here versus speeding up, slowing down. So they have some points that are going on this curve. Okay, so I have one behavior that's happening from 0 to 2 minutes. So I'm going to do it like this, 0, comma 2. Then we have something is happening from 2 seconds to 4 seconds. I don't know if this is seconds or minutes or whatever it is, but let's just say seconds. Okay, from 4 seconds to 6 seconds, it's cutting off and doing something else. And then from 6 seconds to 7 seconds, it's doing something. And then from 7 to 10 seconds, it's doing a last thing. So we have those 5 chunks on our graph. All right, so let's see what's happening here. This is increasing, which means plus for velocity. It is concave up, which means plus for acceleration. Since those two are both the same sign, this is speeding up. Okay, this is just the position function. This is showing me what my ant is doing. My ant is underground right now. Now he's crawling up the hill, etc. Okay, from 2 to 4 seconds, this is increasing. My velocity is plus, but he's caving downwards, so my acceleration is minus. So at that point, I'm starting to slow down. Okay, from here to here, from 2 to 4 seconds, I'm slowing down. All right, now this guy is decreasing, so he's negative for velocity. That's first derivative, decreasing. But then he's concave down, so he's negative for acceleration. So I've started to speed up again. Okay, and then here from 6 to 7 seconds, I am decreasing for velocity because I'm going downhill. Okay, and then he is concave up, so he's plus. So that means plus for acceleration because those two are opposite. This is slow down again. Okay, and now this one is a little bit confusing. He is neither increasing nor decreasing, nor concave up nor concave down. This ant is just over time, as soon as he gets to this spot, he's just like sitting on this rock from 7 seconds to 10 seconds. Okay, so here's the deal. Think about like he's sitting on a rock. He crawls down into this spot and he's sitting here from 7 seconds to 10 seconds. Okay, because that's how that goes. And my, like, let's pick some tangent lines, right? Tangent line, tangent line, tangent line, tangent line. My velocity would be 0 because the slope of each one of these tangent lines is 0. And if my velocity is 0, the derivative of 0 is also going to be 0. So my velocity and acceleration are both going to be 0. This ant is just sitting on this rock and he is not moving up or down at all, meaning he's not moving. I have no velocity there. Okay, so here he has no movement. So he is neither speeding up nor slowing down from 7 to 10 seconds. There's just nothing going on there. Okay, so hopefully that helps to like distinguish some of this stuff. You could draw some curves that represent your velocity and acceleration, but I don't want to snow you too much today. Yeah, let's talk one more thing. There is a place right below example 3 that talks about this right here, speeding up and slowing down. Okay, so interpreting the sign of acceleration, it says a particle in rectilinear motion is speeding up when its velocity and acceleration are the same sign, and it's slowing down when they have opposite signs. So, question, if the acceleration is 0 over a certain time interval, what does this tell you about the motion of the particle during that time? So my acceleration is 0. I'm not accelerating at all. Okay, so think about this in terms of a car. If I'm not hitting the accelerator, I'm not hitting the gas pedal, but I'm not hitting the brake pedal either, right? I'm not hitting the acceleration. That doesn't necessarily mean I'm stopped in the car. That just means my velocity equals constant, right? And think about what constant means. Like in terms of constant would be like 60 miles per hour, right? Like 60 is a constant number, no variable, right? It's not 60x, it's just 60. It's constant. What would the derivative of 60 be? It would be 0. So acceleration is 0 if my velocity is constant, okay? So that's what that means. It doesn't necessarily mean I'm stopped. If my acceleration is 0, I'm just not accelerating. I'm just coasting, right? I'm just coasting or, whatever. My velocity is constant at that point. So your velocity looks like this on the curve. It's probably doing like one of those. I'm staying at a constant velocity. Okay, whether it's positive or it could be a negative velocity. If I'm like, I don't know, falling toward the earth at the same velocity all the way through, which usually doesn't happen. I guess usually you speed up as you move toward the earth. But I guess if I've already hit, terminal velocity and I'm coasting at terminal velocity for a long time, I'm at negative velocity right here. Okay, so your velocity is constant. It's staying at constant 60 miles an hour or negative whatever. You are not accelerating at all. So that's what that is talking about. Hopefully that didn't snow you too much. That was kind of a lot. This section itself is kind of a lot. So just sit with that. If you want to start the homework, I'm going to give you time to work on these problems tomorrow. But 2, 6, 18, 28, that's what I'll have you guys work on tomorrow. You can work together if you want. But those, try to have those done for whatever, Thursday, I guess. Try to have those done for Thursday. Okay?